without further ado, here's the agenda for today's talk. Quickly go over some context setting to try to see, try to say the importance of understanding data cap flow. And then next, I'll move on to quickly defining what's anomaly detection in our context, and then what characterizes anomaly and what are some archetypes we have identified in the network. And next, I'll be talking about Phil Plus Canvas, which is a product we're building. It's an analytical solution that's trying to model and quantify and detect and ultimately prevent any types of suspicious behavior that's happening inside the network. And finally, I'll close with what's next, and also Phil Plus Watch, which is a separate visualization layer we're building. Cool. So I think a lot of speakers has touched on this. So quick two interesting statistics. We have seen huge adoption of Phil Plus among the ecosystem. And as of most recently, I think the daily active deals attributed to Phil Plus is actually around 88%. And the new committed deals measuring TIB is almost 100% attributed to Phil Plus, which is really demonstrating the adoption of Phil Plus among the ecosystem. So great success. Kudos to the team. I think we would argue that as Phil Plus scales, it is very imperative for us to understand how the data cap flows throughout the ecosystem. So here on the slides, you see a pretty simple bow tie graph. So you have your data cap flowing from Notary to clients to their data cap applications, and then from clients ultimately to storage providers to data cap spending. So that's a very simplified framework of basically how data cap works. We will argue that modeling data cap flow has four main benefits. So obviously, starting from number one, you have reduced cost and complexity to monitor the adoption of the Phil Plus program. And on top of that, you can also model and visualize different types of incentives or interactions that's happening between the actors, which is also very interesting to look at and a lot of deep insights and interest to look into. And actually, what we're more interested in is to detect and kind of prevent any type of anomalous behavior that's happening inside the ecosystem. This is very important to both, promote the governance and health of the network, but also at the same time, it's to promote the fairness among the players that are playing by the rules and then actually contributing to the system. And finally, we can, on top of that, quantify actor reputation to drive long-term network health and governance. So in particular, our product is concerned with anomaly detection and prevention at scale. And we'd argue that is very key to the network success in the long term. So on the left, you see your familiar bow tie graph, but then on the right are a couple of examples of anomaly archetypes that we have observed. So your first type, which is when hypothetically the clients are kind of colluding together with storage providers, and then they sort of in their mind have a predetermined set of storage providers they'll channel their data cap flow to, but basically without any type of proper DD that's happening. So we think that this behavior is relatively easier to detect through proper data sets that's recorded on chain. And then interesting thing is these storage providers usually belong to the same owner. So they have actually the ultimate beneficiary of this type of behavior is like relatively like concentrated into like one or a couple of very few entities. Next, moving on, another top layer complexity, which is when Notary could theoretically also participate in this type of collusion behavior. This is relatively like a little bit harder to detect because you have to substantiate any sort of suspicious behavior between notaries and clients. So this is a little bit hard to substantiate, and where we believe that this is sort of the next step on top of the first type of collusion that's happening. And yet another more interesting type of anomaly that's happening is that we sort of observed that the same set of notaries are kind of channeling the same set of data caps to storage providers, but it's through a transient set of clients, which is to say that the clients kind of disappear. They only do one deal and disappear, but then ultimately who benefits from actually the data cap flow are the same set of storage providers. So I think to detect anomaly at scale, what we're trying to create is Phil Plus Canvas. and we're collaborating with Deep and Galen, so the governance team. And then we're doing this iteratively. So we start from ideation, which is to hypothesize any type of behavior that suspicious actors could have. For example, channeling data cap to the same set of storage providers. And then we formulate these behavior into risk metrics. And then next, we implement these risk scores, test effectiveness against a known list of anomalies. And finally, what we are thinking in terms of production is V1 is a simple reputation system, could be a weighted average of the most effective risk scores, versus V2 is a more advanced analytical solution to do like clustering, graph algo, even ML on top of these risk scores. So by far today, we have identified already quite a few effective risk scores that can detect this set of suspicious behaviors within the ecosystem. So we divide the population among like two groups, suspicious clients and other clients. So the suspicious clients are sort of a couple examples we're working on and subject to change, but this is based on Galen's investigation, are like relatively suspicious clients that we should look into. And we're here on the screen, I'll be presenting 3 different risk scores we have designed, which is quite interesting. Number 1 is concentration score as related to owner IDs. So this it's a score measure from 0 to 1, which measures how concentrated the deal flow are from clients to storage providers. We observed that among suspicious clients, this concentration is very high, like very much close to 1, versus other clients are 0.78. Another interesting thing is average price paid per unit stored per epoch. This is also very interesting to observe that between suspicious clients, this is 0, versus other clients, it's 11. So we believe that this also kind of makes conceptual sense, because suspicious clients, they don't really have the incentive to pay for the deals. But I think their ultimate goal is rather to directly channel the data cap to their predefined set of storage providers. And last but not least, there's another metric called minimum time between any data cap allocation activity and the next deal proposal. Among suspicious client group, this time is roughly just 1 epoch, versus the other group is 850 epoch. Also very interesting to observe and makes intuitive sense, because these set of clients already know that they are going to channel their data cap flow to these set of storage providers. They don't have to perform a due diligence on top of that to really examine, okay, these storage providers are relatively better, so I'm gonna like do some due diligence and then afterwards store my deal with them. So with all these said, I think there's a couple challenges we're still facing. So for example, anomalies are very easy to detect, but it's hard to substantiate. So this would require continuous investigation and collaboration with the ecosystem players, especially Deep and Galen and the governance team, to really substantiate these types of suspicious behaviors. And then on top of that, we believe that actor could also adapt to evade any type of detection that's happening. So if you imagine this is sort of a game theory thing that's happening, actors could adapt to whatever like governance behavior we introduce to the ecosystem. But I think that we can combat this by designing risk scores that so that if they have any deviation away from their risk scores, it'll be against their incentives to do so. So we're trying to design the risk scores in a sort of robust way to like prove any type of to still make it prove to any kind of adaptation from the players. And finally, we are still kind of working just on-chain behaviors, because we are kind of using the data that's being recorded on-chain. But in the future, we do think about expanding to any type of off-chain anomaly detection, including using NLP techniques on any sort of deal application, data cap application, or any type of deals that's being recorded on GitHub, for example. Finally, last but not the least, we're also building another product called Flow Plus Watch, which is a visualization layer on top of Canvas. It's one of the functionalities. Basically, you can do sub-community graphs, which visualizes the data cap flow from notaries to clients and ultimately to storage providers. So it's another interesting thing we're working on. I think I'm at time. Thank you, everyone.
So David, is this available right now in public?
It's still in stealth mode. We're still collaborating with Galen and Deep at the moment, but I think we do have a pretty good prototype already, but we just want to really test it iteratively with them to really make sure that the risk scores are capturing actually suspicious behaviors, but not like any type of other things. because these things are relatively very sensitive. Like calling some people an anomaly or like suspicious is very hard, strong thing to say. So really want to test it out before making it.
Totally. And it will be public, right? Meaning it will be accessible to anyone in the ecosystem to see.
Yeah. That's the intention. Yes.
Gotcha.
+1 from above. The goal is definitely to have this be public.
Thanks, Steve.
I think my question is just quick follow-up, but when you do make this public, are you also going to make public the criteria for what is considered a suspicious client?
That's an interesting product design question. I think, yeah, I guess maybe Deep, do you have anything to say about this?
Yeah, I think a very good topical question. I think a difficult question. I think it's kind of up to the community to define that, and maybe even the word suspicious is not a good word. Okay, then like maybe we need a better word. There's also cases where like projects themselves could be defined as not being compliant, quote unquote, like with certain guidelines or policy. But the same client or the same entity could, in a different world, be compliant with policy. And so we probably need to do a little bit more thinking on like how we want to term these things. And that's part of also why like there's still brainstorming and back and forth happening. If you have suggestions on like terminology that we could use that is more sensitive to the topic and like more appropriate and sort of recognizes the complexity of the situation, we'd love to hear it. I think our operating terms are more for the simplicity of communication in how we iterate in the program today or iterate on the projects today, as opposed to like correct, given like the nature of the situation. So
Steve.
today it's more like exhibiting behavior that we consider to be potentially abusing data cap. And that's really how we define suspicious. So like leveraging it for self-dealing, leveraging it for disproportionate deal making with a small cluster of storage providers, like profiteering from data cap, or like generally bypassing the system to get disproportionate allocation.